start and I okay, record is starting, and now we can start our workshop. I think Mohammed, you should start it today.
Okay.
Please show your screen.
Okay. Um,
Okay. Okay. We see. Please. Uh, mm, can we?
yeah. Okay.
Can you zoom?
Sure.
Yeah. Okay. Okay. Fine.
It's
Please
okay.
start. Yes. Yes. Well.
Okay. Uh, I will talk about CNN and image classification using CNN uh, technology in PyTorch. Okay. Introduction about image classification is the technique to extract the picture from the image to uh, categorize them in the defined classes. It is common sense problem for the human to identify the image, but for the machine, uh, it's definitely not. At first, we have to train the machine with the image, and later, when we introduce the model with the new image, then based on the training, it will give us significant result. And from classification object like in self-driving car to identifying blood cells in healthcare industry, from identifying defective item in manufacturing industry to build systems that can classify persons wearing mask or not. That's image classification used. First, PyTorch is the open source machine learning using in uh, GPU based on GPU. um, Based on Torch Library, it's a measure used for applications such as computer vision and neural language processing. PyTorch is primarily developed and maintained by Facebook AI Research Lab. It's free open source software released under the modified BSD license. Uh, PyTorch is a Python package that provides two high-level TensorFlow and deep neural network. Okay, what is CNN? We can get a input image, then the architecture of CNN make some convolution and pooling, and in deep learning, neural network is a class of deep neural network most commonly applied to analyzing visual image in a facial neural network (ANN). CNN are widely used for image classification, object detection, and face recognition. It is, CNN showed promising results in achieving above mentioned tasks. In simple words, for image classification, CNN take image as an input and process it and classify it as a specific category like person, animal, and car. Mainly, CNN have three types of layers: convolutional layer, pooling layer, and fully connected layer. We take example of are selected for shape. We have a shape first of will define our CNN model that consists of several layers of neurons, depending upon complexity of image, as our dataset has only 4 categories of shape and image are similar. Next, for a CNN model successfully classify image into their respective category. It requires a training. In training phase, we flood our model with we manage models. The CNN model extract unique feature from image and learn them. Once model achieve permanent accuracy, training is stopped and that model is saved for late use in testing image. Deeply learned classifier for age and gender prediction of unifiltered face. Um, this is a CNN technique using for training image and image pre-processing. First, for prediction, image pre-processing and face detection, landmark detection, and face alignment. This is a level of image to predict or train this image. Intelligent age and gender classifier takes a classification task under unfiltered real-world setting. Most of these face images are not aligned and nor frontal and also with different degrees of variance in both appearance, lighting, and background condition. Therefore, those in the wild face image need first to be detected, then aligned, and finally used as input for the classifier. Uh, this photo uh, about face detection, how to detect face, or how machine to detect face by aligned face. And we can using OpenCV for edge detection with deep learning. Edge detection is the process of automatically screening the edge of person slowly from photo of their face. Typically, you will see edge detection implemented as two stages. One, detect face in the input image video stream and extract the face region of interest ROI and apply the edge detector algorithm to predict the edge of person. Um, in regression detection about edge, uh, regression output between like edge between 25 and 25 and 13. Okay, that's all, and this is reference.
Okay. Can you hear me?
Yeah.
Okay. Okay. And can you show your results in Colab, or or you can't have?
I have result
Don't
in
have.
lab, but not in this presentation. I have a result in machine learning with Dr. And uh, in RGB color and how to use filtering in RGB color, not in this data set. But I can make data set about shape in PyTorch to train this data set. I have the data set and I can use it in Colab.
Okay, understand.
But I have if you wanna see my workshop machine learning, but not this presentation, in other task. I can show you.
Okay, 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 understand.
I can show it. I can show it.
Yeah, okay.
Um, yeah. I think this. Yeah, this workshop about how to save corrupt image using color format, about color and filtering GRB format, something in photo, not training photo. Hello?
Yes, we can. We see.
Yeah, this workshop about the photo, input something, input some color, RGB, crop photo, and resize the
Uh,
photo.
ah, I
Not
I now
one.
understand. It is from lesson of Professor Dolganov. Yes.
Yeah, this
Ah,
task I solved it by Professor Durgana, but not related by my design workshop.
yes, it is, but it is different.
Yeah, yeah,
Yes, and I ask about your design workshop and your future master thesis.
yeah. My design workshop now يعني I wanna ask about how to continue about in I should now I should to get some I have data set in this workshop in this presentation to
Mm.
make it I should make it in PyTorch and TensorFlow, right? This is a workshop.
In our workshop, we use PyTorch, and we try to solve the same task but with PyTorch. So maybe it is different.
Yeah.
And our workshop is practical. So just I get you some task, for example, some working notebook, and you try just to run them and a bit change. For instance, change the size of image and etc. So I hope that you just trying to run, and if you have any questions, you just write this question in your report and we discuss them.
Okay. Okay. Thank you, Dr.
Yes, you should see your task in YouTube. I sent links in MS Teams.
Yeah, I understand.
Okay.
But Dr. Zeusen, I wanna make it for a generative how to using image processing by Gen. This is my uh, this is my scientific topic.
Yeah, you mean that how you can
Yeah,
transform this task into medical sphere?
yeah. That one
Yeah,
I'm.
of course, but this is the first task,
Mhm.
and this is the main important task: how we can classificate image, how we can do this, and after understanding, you can apply such methods for image segmentation. I hope that in the end of this semester you can fit and plot model for image segmentation, and you can segmentate, for example, left ventricle on images.
Okay.
And it will be your first task for this semester, just segmentation, because the main goal of your scientific topic is image generation. So, and this is the next stage.
Yes.
After understanding some basic idea of convolutional neural network here.
Yeah. Then first I should to do it in PyTorch, right?
Yes.
Okay.
So you should start with digit classification and improve or maybe modify this technique for face classification, for example, gender classification using faces. Yeah, and after this, race classification and age classification. Yeah,
Age
ages.
classification.
So, and after this, we can discuss with you how you can transform this neural network for your medical sphere, for example, for ultrasound images. And of course, it will be the next task. I understand that all layers in neural networks and all details is not understandable now. Yeah, but of course we have the course of computer vision which will start in April. Yeah.
Yes,
And we discuss in detail.
Yes. I have other questions. Sorry for that. How I can to implement PyTorch in Colab? This how to implement some code of PyTorch library in Colab. This is right? This, can I make it, or I should to install PyTorch on my laptop? So I don't have enough GPU to train image. I can use it in Colab, right?
Yeah, in Google Colab, you can see that the tab. One moment. We discussed it previously.
Okay. I will see previous lecture. Okay.
Maybe one moment. Just
Okay.
Colab. You can see my screen, yeah?
Yes.
Here is the runtime. Change runtime type. And
Yes.
here you can
Using GPU. Yeah.
save. And here you can just check that everything is correct. NVIDIA SME, it is just methods from CUDA library, which shows you available devices, available GPU devices here, and you can see that it is a Tesla T4 with 16 gigabytes of memory.
Okay.
And you can use it.
Okay, Mohammed, you should better prepare for next week's workshop, and we will wait your results. Okay?
I will make a great workshop.
Okay. We will wait. Okay, and
I'm sorry for my absence about previous lecture because my work, and I leave my work to free for this. So sorry.
okay, understand, and we will wait your results.
Thank
Okay, do you have any questions?
No, that's all. I asked my all questions.
Okay, and I think it is good for you to watch other questions with other students. It is good way to understand
Yeah,
this
true.
this topic.
Yeah.
Okay, and I think we can continue. Ali, can you show your results today?
Yes, Professor.
Please show your screen. Fine. Okay.
Okay.
Okay, let's start, please.
Today, talk about age classification from visual images. Introduction. Visual image processing has attached a lot of attention in the computer vision community over the last two decades. A classification of age group based on facial features and age group classification including puppies, young adults, middle aged adults, and all the adults are used in the classification system. The 2-3 faces, location, features, extrication, and age classification. The human face can reveal important practical characteristics such as the identification, gender, race, emotion, pose, age. Yes, among this characteristics, the age information has it is particular importance. The ongoing progress is complicated, non-reversible, non-reversible, and controllable. Eye is affected by various factors, including the living environment, climate, health, lifestyle, and biological reasons. Age-related facial image processing is being extensively studied, and the facial age group classification is one of major research topics in the array. Age estimation can be done more accurately if it is worked on groups containing in narrower age range. Hence, the age group classification problems is in intersecting one dimensioned further efforts. The figures 1 show a structured vision framework for age group classification. And generally for prediction of continuous variables, recognition methods differ from the essence of implicit training data and can get superior accuracy on homogeneously distributed data set, while classification methods are difficult to discriminate adjacent variable values. Boundary effect in adjacent age groups, but they are effective for a course generate prediction, even if the data set is implanted. So classification and recognition methods are complementary in the case of implicit training data. Task can play immediately referencing role in age estimation through multitask learning. Then, according to the incremental calculation of age, we be from age classification by divided age info 5 or more age groups like baby 0 to 2, child 3 year 4 10, youth and adult and middle and old age. Yes. Table 2 show the number of images in age group in the FGNet image database. On this figure show about what one can eye token. Now age grouping, since human going is a conscious and gradual process and phase of adjacent age usually look alike three. There is strong correlation among adjacent age, many extending divided and conquer methods divided the age range into independent groups from classification and level out of consideration the relationship between adjacent age groups. In arbitrary age grouping will lead to the boundary effect on classification. One sample near the boundary of two adjacent age groups can be classified as other on the age feature space is heterogeneous according to age. Causal data protection can not deal with the heterogeneous data distribution only with the homogeneous data partition, local recognition and divided homogeneous age groups can will fit the heterogeneous data. Adjacent age clustering is a strategy which makes adjacent age be grouped stage to explore the relationship between the real age and its adjacent age. We grouping methods science face again is a slow, continuous and extremely non-stationary process with much random news and sampling explosion the range of the age level for clustering. However, we do not have extensive knowledge of face again, which age range will make the face going homogeneous. So we determine the partition of the age intervals by trial and error. Age classification using frontalized facial image. The step of facial image are illustrated in figure 3. Standard pair processing convert image from color to crystal and after looking the center of the eyes, the image are rotated, scaled, grouped and aligned. In our methods, frontalization register a two-dimension facial image, a 1 to 3 dimension facial model, where both size and alignment are normalized. On this figure 3, explain what I took. Yes. And now talking about neural network to classification in age range. Neural network have been used for classification peer process for a very long time. They provide benchmark result for the given problem. It is not ours, but neural network work to collect features from the input data image. The first step in any machine learning problem is to figure out what kind of input data you have access to. For example, here are some things you met now about a person that could be useful in predicting their age. One picture of their face, facial features, wrinkles, hair color, cold, all correlate with some age groups more strongly than others. and breaches history, spending habits world legally correlate strongly with the age group. For example, student viewing textbooks versus peer parents buying debris. On the data of birth, don't even need machine learning at this point, just do the math. And talking now about great age grows from age columns pandas. First of all, import pandas as PD and name X train data and BD data frame. Here I choose any age from any one, like 1 year, 3 year, and bands this 0 to 2 years and 3 to 8 years, 0 to 2 years in step labels in infancy, and 3 to 8 toddlerhood. Yes, add another 3 to 12, 100. Yes, and using pandas cat with biometry, right false for not included the rightmost age of pandas, and last code, last for replaying mission value using added catering with the filing this no and input this code here, number and age, 1 year, 3 year, 5 year, equal age groups. In fantasy, toddlerhood again, yearly childhood, middle childhood, and I write here negative or -3. This point read in none, and 200 the same. Conjugation in the majority of the methods proceed for age classification from facial image. They processing step consist of alignment and elimination, correlation followed by the extrication of features which are forwards to a classification to estimate the age groups of the person in the image. Age estimation of facial image is very challenging and is still not solved all. Classification is an auxiliary task to post the generalization performance recognition task and a good age grouping for classification is also important for the recognition task. We should consider the balance of performance and complexity because as deeper network can lead to larger network architecture which requires higher hardware configuration and larger training data set. On this demograph in workshop I talking about in workshop
Great job.
Thank you, Professor. And here ask me Professor Zuzin to type code of classification age groups to in 116 and added then yes or yes here I not added this code because I need learning more about I need just like this pins or all this code right here and in neural network. Yes, I added a convolution layer, but here I think no except float or error here.
Yeah. Understand.
Yes. Finish.
Okay, I understand. So, but if not added additional layer, can you train your model or not? I see that you have the last fully connected layer with the two outputs. But for your task, I guess you need more than two outputs neurons. You can see the self.fc2 equals and then linear 15 and 2. 50 and 2.
Yes, and I change this in 64 and 4.2.
No. It is
No.
not good. I guess.
Yes, yes.
Yes. If we stay this the last one, 32 by 13 and 13 here, not 64. 13.
Yes.
13 to 32. Yeah. No. Yeah. 32.
Yes.
So, and you can see that your neural network output just 2 neurons.
Yes.
Below.
Below?
Yeah. No. Just FC2.
FC2. This. Yes.
No, a bit lower.
This?
I guess below. I guess 3 or 4 strings below. Self.fc2 equal and then linear.
Linear. This.
Yeah.
This.
And below, yeah, this one.
This.
It is the last layer. So this last layer predicts your age gender group. And the last number show how many groups you want to see. So you stay here 2, but 2 it is correct for gender classification when you can try to predict male or female. Yeah, because only 2 groups.
Yes.
But for age,
for age, yes.
You need more than 2. And for instance, in your report, you told us about 7 group, I guess. Yeah, yours, middle age, old age, and etc. I guess you determined 7 group here. Yeah.
Yes.
So if you write above, sorry, can you show above code in above? So well, here, yeah. Low. Stop. And below, and below a bit below too. Below.
This age.
Age now. This age means integer value from 0 to 116. You need to divide these ages into groups. Yeah, and you show us below, I guess, something how you can divide it a bit below.
Sorry, Professor, can you using this code or not?
Oh, yeah, here. Just stop. Okay, here you determine beans. Yeah.
Yes.
So beans determines the groups. I guess that you try to divide it all ages groups from 0 to 3, from 3 to 8, from 8 to 12, from 12 to 19, and etc. Yeah, because it is like a groups for classification.
Please, can you show me?
Okay, let's try. May you send me?
Maybe later. Okay, now I send you. Oh, where message? No. I think cancel message here.
Okay, maybe I try to. Can you see my screen? Yeah.
Yes.
Okay. For instance, one moment. Maybe I just write something here. So you have convolutional neural network here, yeah, CNN. The input of this convolutional neural network is RGB image with size 64 by 64. Here some faces, for example, yeah, some faces. So you have R, G, and B channel. So for a PTorch, this is a tensor with size 1 by 3 by 64. Yeah. And just remind you that if we use two convolutional layers, conv layers with kernel size equal 5, it means that we transform this tensor into tensor. I forget. First layer with feature maps 16, and I guess the second is 32 feature maps. So you will get after the first layer and max pool. Yet here is max pool. Maybe. Okay, let's write like this. So first conv layer and max. We will get feature maps with size 60 by 60, and the number of feature maps here will be equal something like this, 16. I guess that we need to understand how we can get it. For instance, if we have some matrix, for example 8 by 8, and we use kernel size kernel size 5. Sorry, we need to add additional rows here and here. It means that we put our kernel size, our kernel here. You can see that we just put kernel in this one.
Yes.
In this one, and we calculate the convolution in this part of image. So we will get the first value of this area. After this, we shift our window, shift to the left, and we put our convolutional window here, and we calculate the next value, and etc. So you can see that we can shift again to here and here. So we can calculate only 4 values. After this separation, we shift through the rows. Here we shift through the columns, and now we can shift through the rows. So we put our kernel here and calculate value here. And after this, we shift through the column, and we will get 4 value here and additional value here, and it will be the feature maps 4x4. It means that if you use a convolutional kernel with 5, you will get new feature maps, which is the size of these maps will be decreased by 4. It means 2 rows above and below, and 2 columns left and right will be we just drop them. It means that we calculate only in this part of image, and we will get just feature maps 4x4. So here, if you use feature maps 64x64, you will get the feature maps 60x60, because we just calculate in this area, and we determine that we want to get 16 feature maps, and we will get the first feature maps here. Yeah. After max pooling layer, you will get feature maps 30, and the number of them will be equal 16, and etc. So if we apply the next block with convolutional layer and max pooling, we will get feature maps. Okay, here C dot. We will get 9x9, and the number of them will be equal 32. So these feature maps just described our are describing our image here. Yeah, there is some information in this feature map, and we can use some classificator for classificate, for example, gender. But for gender classification, we use some fully connected layer, and okay, let's write like this, where these feature maps transform into linear some linear vector. Yeah, linear vector. For example, for instance 50 maybe. Yeah, and this fully connected layer can be classified any classes, and for gender classification, in the end of this neural network, we just put only 2 neurons. First neuron tell us about, show us that this face is, for example, male, and the second show that this is a female. So where value is more, it means that this is, for example, if this value, okay, let's write like this, T1, T2. If T1 more than T2 means it means this is a male. If T1 less than T2 means that female. So the same scheme can be used for gender classification, for age classification, but of course you need more than 2 neurons. For example, if you want to classify only 3 groups or 4 groups, okay, let's write like this: age, example, youth, middle age, and old. So you need to add additional neuron here. So your neural network will be classified 3 groups, and you will get the third value, which show us which is the group. For example, T1 can be yours, it is the middle, it is the old, and which value will be more means that this is from this group. Yeah. So in your collab,
I send now a task. Yes.
Okay, let's try. Runtime change, runtime GPU. May I request access? Okay. Okay, we need to pre-process data here, for example. Yeah. Okay, let's change here like this. Okay, now we pre-process our data sets a bit. Yeah. So I guess that 200 images is enough for us. Okay, and here. Okay, just stop. So, okay, let's see here. We can, now you just have age as a value from 0 to 116. But in this function, you need to transform your age from this range into 3 groups. For instance, you can transform into 3 groups, for example, from 0 to 16, from 17 to okay 65, for example, for instance, yeah, and from 66 to okay, let's write something like this. All ages which is more than 66 will be the last group. Yeah, this is the 0 group, this is the 1 group, this is the second group. So for this you need to write some code here. Yeah, for example, sorry. Class gender, and let's write maybe with something wrong with my keyboard. Okay, if age less than 16, so you have class gender equal class gender equal 0. If age less than equal 65 is the class, sorry, not gender, class age equal 1, and else class age equal, sorry, yeah, we need to don't equal 2. So that's enough. Class age, and your class UTK data sets now return image and class of age group. Yeah, you can see that. For example, you can determine more than 2 classes. It's just another method how you can transform your real age into classes. So, and after this, okay, let's run. Here, and here we change. We can. I just remind that we have only 3 classes, so we need to change 2 by 3. If we determine more than 2 classes, for example, we need add some additional class here, elif age less than equal. Let's write, for example, 35. So class age equal 1, 2, and 3. For instance, yeah, we just need to add 36 and additional classes from 17 to 35 will be the first class. 0 class, 1 class, second, and the third class here. So continue. Just run, creating train data and valid data from the process path and process path 2. And here we change the last fully connected layer with 4 neurons for 4 classes. Okay, let's try. And we check that everything is correct here. Everything is correct. Okay, you can see that we have 4 classes in the output layer for class. And now we just check that everything is correct. Test loader, train loader, iteration, class H, local variable reference before assignment. Look here what happened. H, class H if elif else class H how it can be. What happened here? Local variable. Okay, let's write equal class H could not insert type of non-type. Okay, need to try. Maybe not here. Try. So let's print class H. Print H. I don't understand what's happened here. Train order. Object of non-type has no len. Has no len. Guess that here denotes total self size. Self size. Okay, we need to debug our class data set. Train data, something here, train data 1. Something wrong in your code, something wrong because it is not self file. But here everything is correct. Two, zero, zero. Split H. Okay, let's try again. Why? 1, 2. Okay, class H. Class H reference before assignment. How it can be? And understand H now equal to H less than 16. We determine class H 0 integer. less than 16. Print less than 16. One moment, what's happened? True. But why we can class age? Okay, happen here, class KLS2. Okay, now it's work. I guess something wrong with variable name. I don't understand what happened here. Okay, let's run again. Train neural network. Now we will get images and class. Yeah. So let's see our neural network. Now we put our neural network into GPU. So, and let's see what's happened here. Okay, let's see. So this is the faces, and we need to determine PLT title, age group plus str str L. Yeah, L means L3 numpy. Okay, let's try. So age group is 2. It means that this man has age more than 17, but less than 35. No, sorry, more than 36, but less than 65. So now we can plot our neural network using the previous code. Oh, you can see that we train our neural net here, but now we use just 200 images for our net. But of course, you need to pre-process more than 10,000 images and train better this task. Okay, so and now we can see that loss function. You can see that train loss is decreased and test loss decrease for the first 2,000 iteration. 30,000 iteration, and after this value, we can see that the test loss is decreasing. It means that we overfit our model, and it is connected with the small subset. We need to use more than 200 images for this neural network. Of course, and we need to preprocess maybe 10,000 images. Okay, now this neural network can predict each group using image of faces, yeah, faces image. So your home task will be try to fit this model, and of course you need to determine groups, maybe more than 5 groups or 10 groups, 10 different groups for training. So, and the last problem is that you can't add additional layer. Yeah. Okay, we can. Okay, let's a bit change here. We just change the kernel size by 3, and it means that the size will be changed like this: 64 by 64 transform into 62 by 62. So after this, sorry, but it is not a good way, maybe. Maybe it is not a good way. Okay, let's go from here, maybe. Let's go from here. We just get additional layer. And for example, we want to see here just a 4 by 4, yeah, the last features from convolutional layer. It means that there should be 8 by 8. So it means if we use kernel size 5 by 5, it means that we need to add 4. Here will be 11 by 11, and here will be 11, 11. So here we will get 24 by 24, and 24 by 24, and here 28 by 28. So, and sorry, 28 here, 28 here, and here we will get 32 by 56 by 56, and 56 by 56, and it means that we need to put into our neural network images with size 60 by 60. And here, of course, we need to change 4 by 4. So now we can check that everything is correct. Search if delete it. Okay, we can check that everything is correct. Identification layer. Okay, let's look. Torch vision, and here we put images like this. Okay, and here we need to change 4 and 4. And here you can see that everything is correct now. So the main problem that if you change the size of image, you need to change your architecture, because you can see that it depends from the input image, for example, 60 by 60, and you will get calculations through each layer, and you will get 4 classes, yeah, for example. And of course, if you try to use another size, you will get errors, because sometimes you can't calculate correctly through each layer. So you need to calculate always for each convolutional layer here. If you want to add, for example, additional layer, of course, you will get some problems. Yeah, some problems. And for example, for this convolutional layer, you should preprocess your image for a size 60 by 60, and everything will be correct. But if you change the size of image, you need to check that everything is correct in your layers. Yeah, each layer calculate correctly. For example, from 60, for example, this image into this image, and etc. I guess that the first lecture from the course of computer vision will be connected with convolutional layers, max-pooling layers, and etc. And we will discuss in details how the transforms are conducted through each layer here, yeah, and how they work for a complete your neural network using this one. Yeah. Okay.
Okay. Thank you very much, Vasily.
Sorry, Professor. This liner 32 or
yes,
64.
Because you have okay, let's just see. You have 32 by 32. It is a feature maps, yeah. Because after max pooling, sorry. After max pooling, you will get feature maps with this size. It means that your feature maps is just a 4 by 4, yeah, and you have 32, 64. Yeah, no, it is not 64. Yes, 64, and here should be 64. Let's look again. One moment. Is invalid. Here 60 by 60. Yeah. So yeah, the main idea that you have feature maps 4 by 4, and you have 64 such feature maps. Yeah, such feature maps. If you want to transform them into linear vector like this, so you need to multiply 4 by 4 and by 64. You just flatten them into linear vector. It means that 4 multiplied by 4 multiplied by 64, and you will get just a linear vector as an input into fully connected layer. Because fully connected layer work with linear vector, not feature maps. Yeah, understand? So here we will get 64 feature maps. After max pooling, we transform into size 4 by 4, and we flatten all feature maps into linear vector and use fully connected layers. Means that like this here, which output something. Okay.
Okay, understand. Thank you.
Okay. Do you have any question?
just added a new task.
Yeah, I
the
hope that
next lecture.
yes, I hope that you continue this task and you train age classification
Okay.
for UTK faces. Means that try to
Yes.
use UTK faces for age classification.
For age. Okay.
You can determine any number of classes of age. Okay.
Okay.
Okay, okay, Ali is great. Dear students, Hun and Mohammed, you should prepare for your design workshop like Ali, okay?
Feel free to send me a mail, maybe with some questions about this work. Okay.
Okay.
Okay, Professor. Thank you.
Okay, and now we continue. Hun, can you show your results?
Sorry,
Unfortunately, please louder.
no.
Can you repeat?
No.
Okay, let's look at your problems. Okay, can you show your problems with your work?
Sorry, Professor. Today I have not no result.
I understand, but did you do anything or not?
No. I communicated some from with Professor Jordan.
Okay, and can you show maybe your some result in Colab on and your some problems or other issues, or maybe do you have questions with this task?
Sorry, now no.
Understand. I hope you prepare your report for this week. Next week.
Okay, and always write questions. Okay, and you can send me on email because it will be more preferable if I just check any questions and try to explain in details how it works. For example, any layers and some problems with code, maybe. Okay.
Professor, about how to write digit dataset. I need complete some code. Only you gave me some code.
Oh, okay. Maybe you can start with handwritten digits classification. I guess that everything is correct in this code, and try to implement digit classification. And after this, we can discuss how we can modify code from digits to age gender classification with spaces.
I mean, if you don't give this code, do I need to complete this code alone?
Okay. Okay.
Okay, Hoon, please send us your question in this week, and we will wait your results at next design workshop. Okay?
Okay, okay.
Okay. And I have one questions for all. Did you learning at web development, web technologies? Do you have any problems?
No, no problems. Continuous learning in web technology.
Everything is okay?
Yes.
Okay, okay, fine. And maybe do you have any questions for us?
Yeah, I have one question.
Okay.
About every task, Professor, could you write it detail? For example, first task is something. Can you hear me?
Yeah, yes, but I hear some noises, and please repeat about your task. What's the problem?
Oh, sorry, one moment. I adjust my microphone.
Okay, okay. Please repeat.
Can you hear me?
Yes, yes.
I see. Could you about my task? The workshop task. Could you write it detail? For example, first task is something. Just step to step. Maybe that I will more clear. What should I do?
Okay, I understand.
Yeah, thank you. I think that's important for my next work.
Okay.
Thank you very much.
Okay, Vasily, please write this task for Hoon more clear. Okay.
Okay.
Okay. Thank you very much. And maybe other questions?
No. Thank you.
Okay.
No more for me.
Okay, and we will see you next week. Okay, and I think all for today. Goodbye.
Thank you for
Good.
all, Professor. Goodbye.
Thank you too.
Thank you for all.
Goodbye.
Bye-bye.
Goodbye.